Okay, these are our notes on sections 3.2 and 3.5 on parallel lines and transversals. The first thing we're going to do is review real quickly what parallel and perpendicular lines are. Parallel lines do not intersect. Okay, they're in the same plane, but they will never meet, and that's what parallel lines are. And this is our symbol for parallel. Okay, and if we had an example of parallel lines, here's a quick example. Okay, those two lines, they'll never intersect. They keep going on forever and they will never meet, so they are parallel lines. Perpendicular lines do intersect, and they intersect to make right angles or 90-degree angles. And this is our symbol for perpendicular. It's that upside down T. Okay, remember parallel is two lines off to the side, and upside down T means perpendicular. Now, parallel lines and transversals, they have some special relationships. Those four relationships we learned in 3.1, consecutive interior, alternate interior, alternate exterior, and corresponding. When there's parallel lines and the transversal cuts those parallel lines, those angles fall into one of two different categories. They could either be congruent or they can be supplementary. The ones that are congruent, and it's important that we understand this, the ones that are congruent, remember congruent means that they are equal, so they'll all be the same measure, are the alternate interior, the alternate exterior, and the corresponding. Okay, those three relationships. Whenever you have parallel lines and those lines are cut by transversals, or you could have more than two parallel lines, but if they're cut by a transversal, these three relationships are always our congruent ones. And remember, congruent means that we set things equal, because they should have the same measure. The only one left is the supplementary one. And remember, supplementary means adds to 180. Okay, and it is the consecutive interior. Or the other name for that, remember we said same side interior. Alright, that relationship is one where we add them to 180. It's the only one that's different. Okay, it's the one where we add to an 80. So if that were the case, we would add the two angles, and then we set it equal to 180. That's how we'd solve it. We have to set up an equation, and that's how we'd set it up. Add our two smaller angles, set it equal to 180 degrees. We got two quick examples here. The first one says find the measure of all the numbered angles in our picture. We know one angle here is 77. We got to find the rest of them. And we're going to use these ideas that we talked about up here, these relationships. These two lines, we're going to go ahead and mark them parallel so that all of these hold true. So if this one's 77, well, that is a corresponding angle with angle 4. So angle 4 has to be 77. 77 is an alternate exterior angle with angle 6. So angle 6 should be 77. And angle 2 is a vertical angle with that 77 degrees. So it is also 77. So right now we've got 4 of our angles figured out. We know the original, and then angles 2, 4, and 6, the even ones, are all 77. Now it's not always going to happen that way, so I don't think that will work every time, that the even ones will always be one number and the odds will be the other. That doesn't work. But in this case, the even ones are all 77. Now, let's figure out what angle 1 is. Notice that angle 1 here and that 77, they make a straight line. So to figure out what angle 1 is, I would take 180, because a straight line is 180 degrees, minus 77. And we get 103. Okay, that's what angle 1 is. Now, angle 1 is a vertical angle with angle 3. So it is 103 degrees. Angle 1 is an alternate exterior angle with angle 7. So it's 103. And angle 5 and angle 1 are corresponding angles. So it's 103. And now we figured out all of the angles in our picture, and we've really just used two different relationships up here in the idea of supplementary. We used alternate exterior. I guess we used them all. Alternate exterior. We could have used alternate interior. 3 and 5, they're alternate interior angles. You could have gone about it that way. Corresponding we used. We didn't really use consecutive interior, but we could. Angles 3 and angle 4. They're consecutive interior angles, so they should add to 180. Once we figure out angle 4 or angle 3, one or the other, then we could have subtracted from 180 to get the other one. So there's a bunch of different ways to do this. But you do have to remember that supplementary angles add to 180, and then all of those relationships that we set congruent that are equal, you got to remember those. Let's look at our second example here. It says determine the values for x and y. Let's mark those congruent. They should be marked already. I guess I forgot to do that. So let's mark those congruent. We got to figure out the variables x and y in our picture. So what we should do is look at ones that have the same variables. Well, this angle here and this angle here, they have the same variables. And we got to figure out the relationship between those two angles. Well, from looking at my picture, I'm going to guess that they are corresponding because they're on the same side of the transversal, but they're not both between the two lines, our two parallel lines. So I know that they're not consecutive interior. They're both above one of the parallel lines. So I'm going to say that they're corresponding. Since these are corresponding angles, if we think about the way we could classify those relationships, corresponding angles fell under the congruent category. And remember, with congruent things, we can set them equal. So we're going to take 3x plus 6 and set it equal to 4x minus 6. And we're going to solve it. So we're going to subtract 6 from both sides. 3x equals 4x minus 12. Negative 6 minus 6 is 12. Negative 12. Subtract 4x from both sides. 3x minus 4x is a negative x equals negative 12. Can't have a negative variable, so we're going to divide both sides by negative 1. And x equals 12. That's a pretty crappy 12 there. Let's rewrite it. X equals 12. Alright, so there's one of our variables. Now we got to figure out y. Notice that the y down here, I put a star by it, the one with y, it makes a line with the one with the x in it. If they make a line together, they are supplementary angles. There's that idea again, supplementary. Remember, supplementary means they add to 180. Well, let's plug that 12 in for that 4x minus 6. Let's plug that in and see what we get. So it'd be 4 times 12 minus 6. Well, 4 times 12, that's 48. Minus 6, it's going to be 42. So this angle here is 42 degrees. And if they have to add to 180, then we could say 5y plus 18 plus that 42 degrees now, because we know what that is, after we plug that variable in, equals 180. Let's go ahead and combine like terms. So 5y, 18 plus 42, that's going to be 60, equals 180. Subtract 60 from both sides. 5y equals 180 minus 60 is 120. Divide both sides by 5 so that y becomes, how many times does 5 go into 120? Let's see, it goes into 12 twice. 24. So y is 24. And we could check that. We could plug it back in. 5 times 24 plus 18. Add the 42 to it, and we can see if we get 180. But now we found both of our variables. We found our x and we found our y. And those are your notes on sections 3.2 and 3.5.